Okay, I don't feel like I did a very good job last time in describing the how we calculate the moment components. So I just want to do that again real quick. So when I calculate moment, oops, what happened there? When I calculate moment, I need the components. Oops, uh, I need to calculate the components of the moment. So I need to calculate m for each component. In this case, I want to think about the centroid has a weight, right? And we can find the location of the centroid for this quarter bar, and we know it's like right around here, and we know that this distance here, from like here to here, that's going to be our x bar, and from here to here, that's going to be our y bar. Okay, and I know that there's a force here, the force of gravity or the weight. Well, I just call it F sub g. And I know there's a tension on the rod. The rod is being pulled to the right by this wire, say, that's connecting it to B. So one thing to think about is I know there's no reaction forces at B because it's just holding this wire in place, right? And once if the wire was cut, B wouldn't have any reaction force. So that really the thing that's creating a force is just the tension in that wire, and the weight of the bar itself. There is a reaction force at C, right? So imagine if the tension is pointing this way, right, then C has to point the other way to balance the forces. And for the reaction forces at C are also up because it has to balance FG. So I've got a CX like that and a CY like that. But we're not going to concern ourselves with that for the moment because we're going to pick our moment origin to be at C. So when I pick my moment origin at C, my radius of any force that exists at C is 0. So I don't have to worry about the moment at C when I'm going to have this, when I'm going to think about this rod rotating about C. So the first thing I want to think about is just if I had just the rod, right, like this is my C. Without if I took away the wire, there'd be no tension. And so all I'd have is just the force of gravity down. And it would cause this to rotate down, kind of like that, right? Um, and so that's a rotation, and so that's one of the components. So to figure that out, my moment for that is just going to be Fg, the force, times the radius. And so the radius that I need is the perpendicular component. So that's what the cross product gives me. The perpendicular component of this radius around C. So C like connects here, and so my radius is really this. I'm going to call that capital R for my moment arm. But the problem is this is not perpendicular, right? They're not perpendicular. So what I need to do is I need to like drop this down and find this piece. This is the piece I'm interested in. That's my R that goes when I say Fg times R, I'm going to pick this piece. So I'm going to say that that's X bar, right? Because that's the same. This distance from the edge here, right, is just X bar. Okay, so there we got that one. And now the tension, if I just had, if I had the tension and pulled it around, right? It's going to pull it around. So if I have this and I were to pull on this and actually really pull on it, it's going to pull it around like this, that way. So I'm going to have a, let me draw that a little better. So I have this with this tension pulling this way, right? My tension's pulling this way. My radius is actually this distance from here to here, right? I could imagine pulling this around and even having it be like here and keeping pulling like that, right? So my radius is just little r. So I'm going to have, this is going to be tension times little r is equal to 0. So that's how I would set them up. And then I could keep going and do the sum of the forces to find CX and CY. And you saw that in the earlier video.